Can everyone hear me? Is this a good volume? Yeah.
I can hear you.
Okay. Okay. My name is Paige. I'm going to be talking about my breviate article, which is Bioactive Contaminants Leach from Disposable Laboratory Plasticware. So, we've all probably heard of the infamous BPA movement, where we're concerned about BPA in our water bottles or baby bottles leaching into our food and our liquids. But what's seldom talked about is processing agents from our disposable laboratory plasticware leaching into our biological media. If it has the ability to leach into our food, why can't it leach into our media? And if it can it alter our experimental outcomes? So this article focuses on that because they found some interesting observations with measuring human monoamine oxidase B activity. They noticed that different Eppendorf tubes of different brands and different sizes seem to alter the human monoamine oxidase B activity in their experiments. So what could be done about this? What types of leachates are we looking at here? So in order to evaluate that, they performed a water and a methanol rinse of two different types of tubes in which they saw a decrease in monoamine oxidase B activity. They extracted the leachates, dried them, and performed mass spectrometry to identify any leachates that might be present. From the water rinse, they determined DIHEMDA, which is a known biocide, and from the methanol rinse, they determined cis-oleamide, which is a known slip agent. So next they wanted to validate and verify, are these agents actually what's causing the reduction in monoamine oxidase activity? So to evaluate that, I want to remind you guys of what monoamine oxidase does. In the presence of an amino substrate and oxygen and water, monoamine oxidase converts the amino substrate into hydrogen peroxide, an aldehyde, and an amine. So in order to evaluate if these compounds have the ability to inhibit monoamine oxidase, we need to apply them in the presence of an amino substrate, apply either monoamine oxidase A or monoamine oxidase B to determine selectivity, and then we need some way to identify the product or the conversion to a product here. So they applied influx red, which interacts directly with hydrogen peroxide to produce a fluorescent compound. So the idea here is, if these compounds are inhibiting monoamine oxidase A or B, we'll see a reduction in conversion to product and a reduction in fluorescence. So in this figure, we'll start with the closed shapes here. They're indicating DIHEMDA, and you can see from triangles, monoamine oxidase A, to circles, monoamine oxidase B, you see a curve shift to the left. And then same with cis-oleamide, except for you see a curve shift down and to the left. This is indicating that both DIHEMDA and cis-oleamide are selective inhibitors of monoamine oxidase B. So next they wanted to test a different assay system and make sure it wasn't just some strange thing going on with monoamine oxidase. So cis-oleamide has been shown to be an endogenous signaling molecule and has also been shown to bind to a number of different receptors in the brain, including GABA A. So in this assay, they used a DMSO-free rinse, a DMSO rinse in a glass control tube, a 1 times DMSO rinse, and a 3 times DMSO rinse. The idea here being that the more rinses you have, the more leachates you're extracting, and the more inhibition that you'll be seeing. So each of these rinses were incubated with a GABA A radioligand and a rat brain, and the idea being that if the leachate can inhibit GABA A binding, then you'll see less GABA A radioligand with the rat brain. So they filtered these after incubation, and then they extracted the filters and counted them for radioligand. And you can see here that in the control DMSO-free rinse, the glass tube, and the 1 times DMSO rinse, you still see a lot of specific binding, but with the 3 times DMSO rinse, you see a significant reduction in GABA A binding, indicating that these microfuge tube leachates are likely the cause of inhibition of GABA A binding in the rat brains. So in summary, I would like to conclude by saying processing agents from these disposable plasticware do leach into the media and biological solvents. These leachates include biocides, slip agents, anti-static agents, and there are many more. And leachates from the plasticware may be a potential source of error in many assay systems, as we saw with inhibition of human monoamine oxidase enzyme activity, as well as reduction in GABA A receptor binding. Thank you.